Hello everyone and welcome to the first ever Statehub webinar in which I will introduce you to Statehub. My name is Michael Greenberg, I'm the head of product here at Statehub, and naturally if you have any questions after this presentation you can send me an email to the address that's on your screen right now. So Statehub is a Kubernetes data service that provides business continuity experience at a quality and a level currently unmatched by any other player on the market. It allows you to eliminate downtime, free yourself from vendor lock-in, and do it with extremely minimal effort, both in setup and day 2 operations. Essentially, Statehub allows you to take your business and data anywhere in real time. We're currently available on AWS and Azure, and by the end of the year in Google Cloud as well. On a conceptual level, we have found a way to decouple your application state from the locations where it's stored. With our application mobility technology we call app warping, when something happens, you can start your applications and resume your business anywhere in the world in seconds. I'm stressing business and data because in most cases, your business is your data. Now, the data side of things has been neglected in the public cloud when it comes to business continuity. Unlike on-prem solutions like EMC's SRDF, we have no proper one-size-fits-most solution for data protection in the cloud. Well, to address that, we're proposing a radical notion that you can actually run your applications anywhere at any time. In the US now, in Europe 5 minutes later, and then shift your entire workloads from AWS to Azure to GCP and back, all depending on your operational requirements, and not dictated by where you happened to create a database 7 years ago, where it has since grown to many terabytes. We call this approach data follows app, and it's diametrically opposed to the current thinking or constraint of app data locality that states that since the data is always bound to a specific physical location, you have no choice but to run your application close to it. So with Statehub, the data is decoupled from the location and you can move your apps, your business, to wherever you need it to be. And of course, it opens up completely new possibilities when it comes to disaster recovery and business continuity. Now, being a Kubernetes data service, it means that we provide our service for stateful applications. I often hear that all my applications are stateless or something like that, which of course they aren't. But whoever says this actually means to say that I'm pretending like my applications are stateless because I've outsourced my state to first-party data services like Amazon RDS, Aurora, Azure SQL, and the like. And this creates some problems right away. And to illustrate that, let's take a look at what Kubernetes business continuity really means in the cloud. In order to achieve an excellent level of business continuity, we need resilient facilities that take care of 3 facets of our IT infrastructure. We need our configuration, our applications, our container images, and the application state, our data, to be ubiquitously available and able to withstand anything that can go wrong. Now, the Kubernetes ecosystem provides adequate facilities for 2 out of these 3 pillars, with the configuration being stored on a Git repository service like GitHub, which is globally available and unlikely to be in the same place taken out by the disaster. I mean, the distributed nature of Git probably means that some of your ops people will have the current configuration on their laptop, so that's pretty resilient. Same goes for the container image registry. This can easily be on a service like Docker Hub or on private registries in a few locations all around the world. They're relatively static and aren't updated too frequently, so pushing images to redundant locations is not a problem. But what about the state? Well, let's take a look at an example Kubernetes cluster on the AWS region US West 2. This can be, for example, an e-commerce operation with a customers DB, an orders DB, and web servers for all static files and media like product images. Now, when designing this architecture, what would be my business continuity requirements? Well, the first priority is obviously RPO and RTO. The RPO is the amount of data I'm allowed to lose when recovering from a disaster, and the RTO is the time it takes to recover and get back to seemingly normal operation. Whoever's done business continuity projects in the past knows that there's this kind of awkward trade-off dance between the two. For example, when I'm recovering from a snapshot or a backup, these are usually from a few hours or a few days ago. This means that if I perform the recovery relatively quickly, I'll lose a few hours or days of data. But if I can't afford to lose any data, I'll have to wait until the problem is resolved. That means potentially a high RTO of a few hours or a few days. Or I would need to go with a more costly solution that doesn't use snapshots or backups in my DRP at all. Next, there's cost. Resource redundancy adds cost. Network setup and egress fees for replication add cost. Complexity adds to the cost in terms of time, salaries, training, maintenance. So of course we'd like something that's easy to maintain and set up. Now it's nice to be very protected and avoid what I call downtime by association. And that means that when you're in a cloud data center with thousands of other customers, wouldn't it be nice to have a first-class golden ticket out of the disaster area to a completely different region while everyone else is still scrambling to understand what's going on and try to pick up the pieces? Also, in some cases, regulators might require you to have up-to-date copies of your data in a certain specific geographical area, so being spread out geographically might also be a consideration. At this point, some of you may be thinking, what are you talking about? We barely cobbled together a BCP with 2 availability zones. We don't have the time and the resources to create something that spans multiple regions. But here at Statehub, we'd like to take everything we know about what's possible, feasible, reasonable, and affordable, and throw all of these assumptions out of the window so we can go completely nuts with the capabilities and experience we can provide. And I'm going to prove to you that business continuity across multiple regions is easy and affordable. And I'll even go a step further and I'll show you the same about multi-cloud. Because sometimes you can't go to another region. You can't move your application away from your customers or your developers or out of the country due to regulation. And you must instead be able to move your operation to a different cloud within the same geographical area. Also, let's remember that you don't own the cloud and the public cloud was not designed around your needs. The cloud vendor might change features, raise prices, deprecate older functionality, and these are a threat to your business continuity as well. Yes, you might know about these changes sometime in advance, but would there be enough time to plan and execute a migration of your entire operation to another cloud if you have hundreds of terabytes of data and you can't afford days or weeks of downtime? So yeah, all these things are what we would like to have within our business continuity plan. But what do most people actually have? Well, they have this: microservices on Kubernetes and the data on a first-party or a third-party data service. Nothing wrong with Amazon RDS or Aurora or MongoDB Atlas or EFS. They're all great services for what they're designed to do, but not so great for what they weren't designed for. And we'll talk about what that is in a minute. But first, to the main point of this slide, they all rely on availability zones for business continuity. Now that means that you can forget about geo-redundancy and vendor independence, which you kind of knew already, but the problem lies deeper with the core reasons for which we're trying to achieve business continuity in the first place, RPO and RTO. While you can probably achieve low RPOs in some configurations, sometimes even zero, actually relying on availability zones when there's a major failure is a problem. You see, unlike a secondary data center that you would build yourself for disaster recovery purposes on-prem, designed around the capacity that you need, the public cloud is a shared resource that's often thin provisioned. That means that while you might do just fine in fire drills, when an actual availability zone failure occurs, everybody else starts competing with you for whatever resources remain in the surviving availability zones. In fact, the cloud vendors run out of certain resources in certain regions all the time. So the likelihood of this happening during a massive failure that is causing a spike of demand right now is very plausible. On top of that, not all regions of all cloud vendors even have availability zones. And many failures that we've seen in the cloud took out entire regions even if they did have availability zones. So relying on availability zones for disaster recovery is not a very good strategy. Which basically means that first-party data services aren't particularly good with business continuity. Because as I said before, there's something that they're not designed for. And that thing is application mobility, the ability to take your application and data outside of the disaster location. Data services like RDS were extremely convenient a few years ago because they saved you a lot of trouble installing and maintaining services and operating systems that they ran on. But today, in the age of Kubernetes, they can all be deployed with a Helm chart, and then you got yourself your very own database as a service. And when you're in control of the applications that are responsible for your data, like databases and so on, you can actually build your own solutions for application mobility, and by doing that, achieve business continuity. But oh boy, is that complicated. First, the network. If you want to replicate to another region, you have to establish and secure communication between the VPCs, and only once you've done that, you can start thinking about the data. How do you get the data to be available at the other location? Will you build replication into the application itself? Will you use snapshot shipping that has a wildly inconsistent RPO? Or maybe database replication? But if you have many application stacks with different replication methods for each, you need people who know them all. You'll need to set up and maintain replication for each database separately and monitor them afterwards. You could also use an SDS solution like Portworx, which would require you to install it on the cluster, manage the storage, and facilitate the replication, pay for licensing, and so on. So it quickly becomes complex, expensive, and time-consuming. Now things get much worse when you want to replicate between different clouds. If you don't want to go through the internet, which isn't too secure and the cloud will make you pay a lot in egress charges, you'll have to provision direct connect and express route and deal with BGP and termination of the connection at a physical location with actual hardware and routers and firewalls. And also, you can no longer depend on stuff like snapshot shipping because the different clouds don't have a compatible snapshot API. It's all a very expensive mess that's going to take months and a huge expenditure upfront. So to recap, first-party data services and their reliance on availability zones isn't good enough on the basic RPO and RTO requirements and leave you stranded and locked in. DIY-style application mobility can improve your business continuity situation dramatically, but it is out of reach for most organizations in terms of complexity, costs, human resources, and time. It is simply too much. Now, obviously, I'm here to present to you a solution that ticks all the boxes, and that solution is Statehub. With Statehub, we're providing the missing piece of the puzzle that is the state pillar of our Kubernetes business continuity in the cloud. Essentially, letting your data behave like your container images. Just specify which container you'll be using and what data you'll be using it with on any cluster anywhere in the world. All that stuff you needed to do in order to establish replication and app mobility, well, we've done it for you and we're bringing it right into your containers. The networking, the replicated volumes, the security, the monitoring, the maintenance, and everything that's necessary to make your stateful applications move around your clusters around the world is included in the package and can be made operational in minutes. Statehub works with any stateful application that takes persistent volumes, so that's almost all databases. And you won't be paying any egress since Statehub provides you with a replicated volume and takes care of all the replication as a part of our service. This means your cloud bill can now be predictable, no more paying for I/O for your replicated databases. The way it works is that by registering your Kubernetes clusters with Statehub, you tell Statehub where the data needs to be. We deduce it from the locations of your clusters, and now we know between which locations we should replicate your data. We then make that data securely available to your containers through the standard Kubernetes CSI mechanism, so you don't really need to do any storage work at all. Now, if something goes wrong, you simply apply your application manifest YAMLs or Helm charts or whatever on the Kubernetes cluster in the other location, and within a few seconds, your business is up and running somewhere else, be that another region, another cloud, or a combination of the two. And I'll show you a demo of that in a few minutes. With Statehub, you can have a business continuity plan with down to 0 RPO, RTO of seconds, global replication, freedom from vendor dependency, and operational in just a couple of minutes, and all of that for a reasonably low cost. We take care of all aspects of the data's lifecycle, its protection and its integration into your Kubernetes environment. Okay, so now let's get to the technical part and to the demo. So what Statehub does technically is it lets you move states between clusters. A state is a collection of volumes provisioned for stateful sets or deployments or pods that together make up an application. A state can span multiple locations and it is available to all of your clusters at these locations. To get started with Statehub, you need to have a Statehub account, download the Statehub CLI, register your clusters, and then simply use Kubernetes like you normally would by deploying your stateful applications, and their data will be on Statehub protected. I will now show you a demo that will showcase the features and capabilities of Statehub when it comes to application mobility, disaster recovery, and ultimately business continuity. I've edited it a bit and removed some parts when we wait for things to provision, but everything I did, 100% of the actual commands are here. All I did before was to create a Statehub account called demo and downloaded the Statehub CLI. First, let's start by looking at our configuration. What do we have to work with? And as you can see, we have 3 contexts here, basically we're working with 3 clusters. 2 of them are in AWS in 2 different regions. These are EKS clusters, one in US West 2, one is in EU Central 1, and the third cluster is in Azure in East US 2. So let's begin. When you create a Statehub account, we create for you what we call the default state. This is a placeholder for your volumes, similar to a default namespace. You don't have to use it, but we create it for convenience. This one has no volumes, no locations yet, and it is not visible to any cluster. Now, if we start registering our clusters one by one, what will happen is that Statehub will find out where they are and will extend this state to their locations. First of all, we're registering the first cluster on AWS US West 2, then we'll switch to the second cluster in Europe, and we will register that, and we will see that the state will be extended to that location as well, meaning that from now on, any volumes that are created on these clusters will be replicated between those 2 locations. But this is not enough. We want to add a third cluster and add a third location as well. So we will switch the context to the cluster in Azure, and we will register that cluster as well. And now we'll see that the default state will span 3 locations. We will indeed see that all of these 3 clusters have access to it. Now that means that when we create our stateful applications, we will be able to move them between those clusters. Now, let's switch back to the cluster in US West in AWS and deploy a simple stateful application. This is going to be a simple MySQL deployment. It's a stateful set. And we can see that because this YAML file has a definition of a persistent volume there, we can see that the volume is now being provisioned, and it's being provisioned in all of the locations right now, and the replication relationship in the background is being established as well. Now, if we take a look at the mechanism of how it works, we can see that the default state is visible to the cluster as a storage class, right? You can see the default.demo.statehub.io. The default is the name of our state, and the demo is the name of the organization, the Statehub account. Now, if we look at the persistent volume claims, we will see that there's one volume here on that storage class, and it corresponds with the name of the volume that we can see in the Statehub console. If we'll take a look at what we actually deployed, we can see that indeed it's a stateful set. It's called MySQL. And if we'll go and look at the volume claim templates, we'll see that there's a volume called dbdata. So a volume claim called dbdata. So that's how we got our PVC name. That's how we got our volume name. And so once this is created, the pod will take some time to come up. And we'll see that we have a pod running. We will now go and start a MySQL Shell, just to show you some replication abilities and how we move the application around with data. So I'll create a very simple database here, and I will create a simple table on that simple database. And now that that is created, I will write to it just like, one row of data so that we can see data moving around our clusters around the world. I've written here the name of the cluster and the time at which this has been created. Now, I'll remove the stateful set because I'm going to need it later, because I need the cluster to be clean later, and I'll switch to my second cluster on which I want to start the application. Now, what I need to do now is give ownership over the state to this cluster in order for it to be able to perform I/O and maybe create volumes if it needs. It also will reconfigure the replication so that all the data that's written here is replicated to the other clusters. Now I've applied the exact same configuration, and we'll see that about 40 seconds later, the pod is up. Now this is running on a different cluster, halfway around the world in Europe, and we see that the data has made it here. Now we will add another row. Select from it, and we see that the data is here. Now we will move not only to another region, but we will also switch cloud vendors. Now, in this case, I'm gonna switch the ownership using the Statehub UI, the management console. And now I'm going to move my application to Azure. Now, in this case, if there was a failure, I simply perform those two operations. I set the ownership and I bring up the application with kubectl apply. Again, going to the MySQL console, MySQL Shell. I can see that the data that I've written when the application was running on the other clusters in the other locations is here. I'll add another one, another row. Now I'm on the Azure cluster. And let's go full circle and come back to our cluster on AWS US West. I'll set the ownership, again using the CLI. And now the cluster in AWS again is owning the state. It means that everything that's written here is replicated to the other locations. By the way, you can use the CLI instead of the UI to do all of the operations. You can see here where the state is available, who's the current owner. We can dig into more information. When I do show state, I can see the name of the state, the storage class name, how it appears in my cluster, who's the current owner. I can see the locations. Pretty much the same as I see in the console. I can see the volumes, I can see the status of each volume in each location, and I can see the private link services. Now we'll apply the same exact configuration. This is why I deleted it earlier. And we can see that it's created and it's running. It takes about 40 seconds. So this is our effective RTO in this case. And if we take a look, we can see that all the data is indeed intact and here. So we've just went around the world 3 times with our data, 3 clusters, 3 different locations, and 2 cloud vendors. Now I can dig even deeper and see what we did to the clusters, what we have installed on them using the CLI, and which states the clusters are exposed to. I can also look at the states from the Kubernetes cluster using the Kubernetes cluster API, and then find out some interesting debugging information. For instance, how we are connected to the state. And we can see that the default state here is connected using private link, and we can see the private link endpoints and which private link services it connects to. These are exposed by our service, made available to your clusters through the Statehub API when your clusters identify themselves with us. And so all of the connection to the Statehub service is private and goes through private link. So this concludes the demo and basically the presentation about Statehub. Now you know what it is and how it can help you to achieve business continuity on your Kubernetes in the public cloud. If you have any questions, please feel free to send them to me via email. If you have business inquiries, please email my colleague Moshe. You can see the email addresses on the screen right now. I would be delighted to hear about your potential use cases. We are now in a private beta, so in order to get on the system, it's available now. You just need to let us know. So please don't hesitate. Go to statehub.io or send us an email. And thank you very much, and I'll see you next time.